engineers working on NASA's Voyager 1 mission have recently carried out a carefully planned poke command to the distant spacecraft, and the response they received has offered a small but meaningful sign of hope in their ongoing attempt to solve a troubling communication issue that has persisted for nearly 5 months. Voyager 1, launched in 1977 alongside its twin Voyager 2, has long been one of humanity's most remarkable technological achievements. Built originally for a mission expected to last only 5 years, the spacecraft has exceeded every expectation and continues to operate nearly half a century later, venturing through the farthest and least understood regions of our solar system. Voyager 1 is currently the most distant human-made object in existence, drifting at an astonishing distance of about 15 billion miles or 24 billion kilometers from Earth. Voyager 2, following a different trajectory, travels slightly closer at more than 12.6 billion miles from our planet. Both spacecraft are now in interstellar space, the region beyond the heliosphere, an enormous bubble created by the Sun's magnetic fields and solar particles that stretches past the orbit of Pluto. Crossing this boundary marked an extraordinary milestone for human exploration, as Voyagers 1 and 2 are the only spacecraft to have ever directly sampled the environment between the stars. Despite their great distance and advanced age, the Voyagers have continued to provide invaluable scientific data, long after the completion of their initial mission to perform flybys of the solar system's giant planets, Jupiter, Saturn, Uranus, and Neptune. Their long-lasting performance has allowed scientists to study cosmic rays, solar wind behavior, interstellar plasma, and magnetic fields. In many ways, the continued functioning of these probes stands as a testament to the ingenuity of the engineers who designed them and the teams who continue to maintain them from Earth, using limited options and decades-old technology. Yet even these robust spacecraft are not immune to the effects of time, radiation, and the harsh conditions of deep space. And in November 2023, Voyager 1 began showing signs that something was wrong. Although the probe continued to send a strong and stable radio signal back to mission control, the information embedded within that signal, the actual science and engineering data, was missing. Instead of transmitting its usual stream of measurements and system reports, Voyager 1's flight data system began outputting a repeating pattern of code that made no sense to engineers. This behavior indicated that something had gone awry in the telemetry modulation unit, a component responsible for packaging and relaying data collected by the onboard instruments. Without this unit functioning properly, the spacecraft transmissions were reduced to an empty carrier wave, a signal that could be detected but not deciphered. The Flight Data System, FDS, acts as the spacecraft's central nervous system for information handling, gathering measurements from instruments studying magnetic fields, plasma behavior, and cosmic radiation, and combining them with engineering data that reflects the spacecraft's self. All this information is formatted into binary code, a sequence of ones and zeros, and transmitted across billions of miles to listening antennas on Earth. But since mid-November, the FDS seemed to be trapped in a loop, endlessly repeating a corrupted sequence instead of sending valid data. This presented NASA with a difficult challenge. While the spacecraft still responded to commands and confirmed reception of instructions, it no longer provided the information needed to understand its internal conditions or continue its scientific mission. For months, the team at NASA's Jet Propulsion Laboratory carefully analyzed every possibility that could explain the malfunction. With no ability to physically inspect the spacecraft and no real-time communication, the signal from Earth takes more than 22 hours to reach Voyager 1, and another 22 hours for the reply. Every test required enormous patience and precision. The engineers explored whether a faulty memory bank, a damaged chip, a software corruption, or an unexpected electrical issue could be at the root of the problem. They studied decades-old documentation, some handwritten or stored in outdated formats, to understand the intricate architecture of the flight data system, which was designed in the early 1970s using now obsolete technology. After ruling out several potential causes and attempting multiple remote restarts of the system, the engineers devised a strategy known as a poke, a command intended to prompt the FDS to switch software sequences or reinitialize certain processes. Because the exact cause of the malfunction was unknown, the poke command served as a diagnostic tool, a gentle nudge that could reveal whether the system was still capable of responding internally, even if its telemetry was disrupted. The command was transmitted on March 1st, but due to the enormous distance separating Earth from Voyager 1, confirmation of any response would take more than a day to arrive. When the return signal finally reached NASA's Deep Space Network antennas, engineers detected something different. Although the spacecraft was still not sending proper scientific data, the nature of the new signal suggested that the FDS had reacted to the poke command in a measurable way. This was encouraging news for the mission team, as it indicated that the computer was not entirely unresponsive or irreversibly damaged. A change in the pattern, any change at all, meant the system was still capable of processing commands, which opened new doors for troubleshooting the deeper issue. The significance of this small breakthrough cannot be overstated. At billions of miles away, the spacecraft operates in an environment filled with cosmic radiation and extreme cold. Its systems rely on aging hardware that has endured more than 47 years of continuous operation. Engineers often describe the Voyagers as elderly machines, resilient but increasingly fragile. Every attempt to alter their functioning carries risk, because a command that might reset a malfunction could also unintentionally disable a working component. Therefore, each step must be planned with meticulous care. Voyager 1's current situation reflects the challenges inherent in maintaining a spacecraft that was never expected to operate for this long. Many of the original engineers who designed the Voyager systems have retired, making the historical documentation essential for today's team. The spacecraft also has limited backup systems. In the 1970s, redundancy was included in various parts of the design, but not at the scale seen in modern spacecraft. As a result, finding alternate pathways to route data or reassign functions requires creative problem-solving and an intimate understanding of the machine's architecture. For now, NASA engineers continue to study the most recent response and plan additional commands to further diagnose the FDS malfunction. Their goal is to restore Voyager 1's ability to send both scientific and engineering data, which are crucial not only for ongoing research, but also for ensuring that the spacecraft remains healthy. Without engineering telemetry, mission control cannot verify whether Voyager 1's power levels, temperatures, or instrument statuses remain within safe limits. Despite these challenges, the mission team remains hopeful. Voyager 1 has survived previous issues, including degraded thrusters, diminishing power supplies, and aging radio systems. Time and again, engineers have adapted and found ways to extend its life. Each recovery effort demonstrates the enduring spirit of exploration and problem-solving that defines NASA's approach to deep space missions. The story of Voyager 1 is ultimately a story about humanity's desire to understand the unknown. Launched during an era when computers were primitive by today's standards, the spacecraft was intended to visit the outer planets and then fade quietly into the darkness beyond. Instead, it became an interstellar messenger, carrying with it the Golden Record, a cultural time capsule representing Earth's diversity, and sending back scientific insights that have reshaped our understanding of the solar system's outer boundaries. Even as it encounters technical difficulties, the fact that engineers today can still communicate with a spacecraft launched almost 5 decades ago demonstrates the extraordinary durability and foresight of its design. As the mission team continues to work through the delicate process of restoring Voyager 1's data transmission capabilities, the world watches with admiration and anticipation. Each signal received, even one lacking usable data, represents a whisper from the farthest reaches of human exploration. And with the promising reaction to the recent poke command, there is renewed optimism that Voyager may first once again send back meaningful information from the edge of interstellar space, continuing its long-standing role as a scientific pioneer and a symbol of what is possible when human curiosity reaches beyond the boundaries of our own world.